All right, this is meant to help you with the terms, definitions, and concepts of Chapter 1. I'm going to assume that you can read, so Chapter 1 really should be not much of a problem for you. Sorry about that. And so I don't want to belabor this, so we'll have a quiz, a super quiz on this, but if you have some problems, use this as a review. So if we look up over in the left-hand corner here, we have a solitary point, 4 point. It's all by itself. And this is the basis for geometry. Remember that the term geometry is made up of a couple of Latin terms. Geom, which means shape, and the rest of it, tree, means study. So this is study of shapes. And geometry really is a very different piece of mathematics. Some people like it, to be honest with you. Some people prefer algebra. But the reality is that it's a very important part of mathematics because it links shape with the language of math. And that's what we're going to do all year. And when we think of the language of math, I'm specifically thinking of course, algebra. Until you get into calculus. Even calculus is based on algebra. So during the course of the year, we are always going to be talking about primarily how we relate shapes to mathematics in the language of mathematics or algebra. So to begin with, the simplest shape, which really doesn't have any shape, it's pretty imaginary, is a point. And it has no dimension. It just is. And we can also have another point here. And if we connect these points, of course, we have made a line. And we could, if we wanted to, make two other points here, and we could connect those two. And if these two lines, line 2 and of course line 1, if these two guys are all in the same plane, then we can say that they are coplanar. And I'll get to planes in a second. Okay? Now, if these two lines, L1 and L2, are in the same plane and they're coplanar, if they intersect, they can only intersect in exactly one spot. It's not possible, in other words, for two lines to intersect in more than one spot, unless they're one and the same line. So we have another term here, intersection. And this intersection right here is green, of L1 and L2, composed of 2 points each. Now, we talked about a plane, and planes are a pretty interesting phenomenon, and I'd recommend that you just think about the floor that you're standing on, or the ceiling that's above you, and think of those as planes. And of course, whether it's the floor or the ceiling, they intersect with the walls. And each one of those can represent a plane, except planes go on forever. And if we define it so, if you look up at these lines, if these lines go on forever, then they are not line segments, but lines. Now, a plane is very often in geometry referred to this way, and if this is plane R, the reference is very often like this, plane R, and we name plane R. Similarly, we could come back here into our diagram and talk about our points here, and if we had point A here and point B here on line 1, we could talk about segment AB, and we would represent it that way. And if it was line AB, we would add the little arrows, which means it goes on forever. Similar for line 2. If we put a couple points there, we would do exactly the same thing. So we can continue this discussion about points. And this is where pretty much, let me get some color here. This is pretty much where the algebra and I'm having some trouble here. Hang on. Okay, I'm back. Here's where the algebra or the math and the shapes can help each other here. So let me get some different color here. Mathematics tends to describe or seeks to describe what is out there. And what we do with points and lines is we say that we have, as I said, the last part, that we have 2 points determine a line, and this line can, if we want, keep going this way and to the right and to the left indefinitely, meaning, of course, it's infinite. So if we think of these 2 points and these two shapes here, we have a segment up here, line segment, and a line down here. Now the important part about this here is, look, here is this line AB. And again, the representation in the book and everywhere you'll see in texts, basically in SATs, is that said, that is line AB. Just to drive you crazy, the definition really of a line is a collection of points. So if you think about it, how many points are between A and B? Well, that's an infinite number. And if we wanted to start at A and go this way infinitely, that's called ray AB, and that is noted that way. We could also start at B and go that way past A and include A, and that is also a ray going in the opposite direction, and we could say that, and that says ray AB as well, but going in the other direction. And here's the thing that should give you a headache. If we look at this line segment here, up here, or if we look at the line, or if we look at the ray to the right or the ray to the left, they are all an infinite collection of points. In fact, they all contain the same number of points, which really kind of should give you a headache. Now, if you're following along in the text, I'm on page 17, and after all those definitions of rays and lines and points and segments and planes, section 1.4 talks about angles. And really, this is nothing more than, if you think about it, intersecting 2 different rays. So let's say if we have ray AB over here, let me grab a nice fresh color here, and ray AC over here. By definition now, we have established what we call an angle here. And if you look at the bottom of 17, you will see a number of definitions. And they are all important, and they are acute, right, obtuse, and straight. Now, these all basically refer to one type of angle, which is 90 degrees, which is straight up and down. And our label here for that is that little square here. So if you see two lines in the drawing and it says that, you are told that that's 90 degrees. So relative to 90 degrees, an acute angle is less than 90. A right angle is 90. An obtuse angle is greater than 90. And a straight angle is a little bit silly. It means, if you are right there, that entirely without an angle, which means it's 180 degrees. So if you're following along, I'm on page 18 and 19 in the text. An easy way to make an angle is to intersect two rays or two lines. In this case, I have ray AB and ray, this would be ray BC. So that's kind of the simplest configuration, right? But I could throw another one in here. What if I put another ray right here that intersected this, and this is ray BD? So now I have 1, 2, 3 rays that all intersect at point B. We say that when this occurs, or as it is here, that this angle is adjacent to this angle because they share the same side, BD. And we represent this by saying angle ABD is here, and this angle is angle DBC. Now, this is very important, the way we do this, because the vertex here has to be in the middle of the nomenclature here. So this says when the reader looks at this, we know it starts with D, but the vertex of this angle is at B. Now, you notice that I've done some little diagrams here. These little things here reference the angle. And we're going to throw in something else here. If I make this little hash mark here and here, that indicates to a person studying geometry that they have the same measure. And again, I'm referring to pages 17 and 18 on angles and their measure. And in geometry, we can do something interesting. So if we have angle ABD, and we have angle DBC, we know that they're adjacent because they share side BD. If they are the same, we don't necessarily have to know what the measure of their angle is. But if we know they're the same, we can write this sign, which is particular to geometry, which is read congruent. And when two angles or two rays, or two segments, or two of anything are congruent, it means that they have the same measure. We don't necessarily have to know what that measure is, but we know it's the same. And it's kind of a nice thing to begin with in geometry and just say, all right, they're the same. We don't know exactly what they are, but they're the same, and we call them congruent. And you have a number of examples of that on page 19. Now, if that is the case, this also means, and we can also reference this entire angle up here, we can say that BD, ray BD bisects the entire angle, angle ABC. The last thing I'd like to cover with you for the chapter is also pretty unique to geometry, although not entirely. You'll see this in mathematics for the rest of your time you take mathematics. And there is certain information or definitions in mathematics, and they come that are given in the text, depending on the text. but they are given as pieces of information that are either need to be proven, have been proven, or are unproven and you can take for being true. And they are all listed, and page 23 is a good example. Now, we have theorems, we have postulates, and on occasion you'll get in this text a corollary. And I think that's probably misspelled. I'm awful speller on the board here. Sorry about that. Now, these theorems, postulates, and corollaries will be listed by chapter. Okay? And here's the good thing for you guys. That because they are so numerous, there's tens of them, probably over 100 or so for the entire year. You can make a note card, and I require that you write this out, but you can bring as many note cards as you wish to class with these definitions, corollaries, and theorems on them. I think it's silly in the course of studying mathematics to make you memorize these things. Not everybody agrees with that. Not all math teachers agree with that, but that is the way that I do things. But I highly recommend that you do that. So if you look along on page 23, there are some introductory theorems there which I recommend that you go over. And I have covered many of them already in the course of my discussion here. For example, if you look at theorem 1.3, it says if two lines intersect, then they intersect. Then exactly one plane contains the lines. Now, I did that way back about 15 minutes ago. I said, look, if we had two lines intersecting, and they in fact intersect, then these two lines are contained in one plane. So please review carefully those theorems and postulates there. And that's about it for chapter 1. I highly recommend that you do the chapter test, review that, and the chapter review, and you'll be all set for our upcoming quiz. We'll move on to chapter 2, and I'll be doing more videos for that as well. Good luck on the exam, on the super quiz, not the exam.